Hi everyone, and welcome to the second video on loops. In this video we just continue the thread that we started in the last video, and in particular I want to do two things. I want to show you some more examples of loops. So loops are like a lot of things in this course where you just have to use them a bunch of times before you're comfortable with them. You just have to see lots of examples of them. So to that end, I'm going to show you a couple more examples, and I also want to show you what can go wrong if you're not keeping track of what the loop is doing or how many times it's running. So I'm going to show you a couple more examples, and then we're going to talk about nesting loops. So just like with if statements, you can have a loop inside of a loop if you want to. And in fact, doing that, having loops inside of loops, is one of the ways you can really unleash the power of C++. So a single loop by itself maybe doesn't do much for you, but in a more sophisticated program, you'll see loops inside of loops all over the place. So the first example of a loop I want to show you is a counting loop. So one of the big uses of loops is counting things. So here's a counting problem. Let's set everything up here. You go to the casino down on the river and you want to play roulette, and you only have $1 in your pocket. So before we continue here, for those of you who have not played roulette before, here's the basic setup. The wheel is a literal wheel, and it's broken up into 38 slots. There are 18 red slots, 18 black slots, and 2 green slots for a total of 38 slots. And the casino worker will spin the wheel and then place a marble in it, and the marble will just roll, and eventually stop at one of the slots. And so basically, if the marble stops at a slot that you bet on, then you win. And if it lands on a slot you didn't bet on, then you lose. So there are lots of different kinds of bets you can make when you're playing roulette, but one thing you can do is bet always on red. And so what that means is you're betting that the marble will land on one of the 18 red slots, and then if it does, you win. So for this play example here, this of course probably wouldn't happen in reality, but suppose you notice that the wheel is broken and the marble is always landing on red. Okay, it's not landing on black, and it's also not landing on green. Well, if you notice that, the thing you should do is bet all of your money all the time on red. That's sort of the best you can do, right? You can't bet money you don't have, so take all the money you have currently, bet it on red, and keep going. So assuming you do that, how many bets will it take you to reach a goal of $100,000? That's the question. And I guess I should also clarify that if you bet $1 and you win, the casino gives you $1, and so now you have $2 in your pocket. If you bet $2 and you win, the casino hands you $2, and now you have $4 in your pocket, etc. So if you bet all of your money and you win, then you now have double your money in your pocket. Okay, so this is a counting problem, right? How many bets will it take till you reach this goal? So let's set up a loop to solve this problem for us. I initialize the variable money to 1 because I only have $1 initially. I initialize the variable bets to 0 because I've made no bets initially. Right? When I show up with this $1, I haven't made a bet yet. And now I set up a loop that says as long as I haven't reached my goal, right, as long as money is less than $100,000, take the value of money and double it. So take the old value of money, multiply it by 2, and save that in a new value for money. Right? Because that's what's happening. You're winning every time, and you're betting all you have every time, which means that you will double your money every time. And what you should do next is increase the number of bets by 1. That's what this bets plus plus does. So every time you double your money, you have made one more bet. And so this variable here is just keeping track of how many bets you've made as the loop keeps going. And then in the end, we'll output the number of bets. So let's see how this works in the program itself. So let's just run this. And it tells me 17. Okay, there's your answer. It took me 17 bets to reach 100,000. So one thing you should do whenever you have code like this, and maybe you're not clear on whether this is working properly or not, $100,000 is a large money amount, and it's not clear how long it should take you to reach that amount. So let's start with something small. Suppose that instead of having a goal of $100,000, my goal is only $2. Okay, what should the program output if the program is working properly? Well, you sit down at the wheel with $1, and you only have to make one bet, and then you win that bet, and now you have $2 in your pocket because you doubled your money. So if your goal is $2, this program should output 1 here at the bottom. That's the number of bets I need to reach $2. And notice it works, right? What if my goal is $4? Well, now I have to bet once to get $2 and then bet again to get $4. So if the program is working properly, it should output a 2 down there, etc. What about 16, right? Well, I have to go from 1 to 2, 2 to 4, 4 to 8, and 8 to 16. So it should output a 4. Okay, so it's working properly. So one of the reasons I wanted to show you this program is it can be easy to lose track of the number of times you want the loop to run. So for example, let's say your goal is $8, right? Well, if your goal is $8, shouldn't this loop run until you reach $8, right? Shouldn't you go until money is less than or equal to $8, right? And so of course if we run this, let's just see, the program says it takes 4 bets to reach $8, but we know that's not true because you go from 1 to 2, 2 to 4, 4 to 8. So it only takes 3 bets to reach $8. So by putting a less than or equal there, we have thrown off the answer by 1. Okay, so why is that? What happened? Like, why is this outputting the wrong thing, even though it makes intuitive sense to have a less than or equal there, right? I mean, you want to reach $8, so go until you reach 8. So if you want to answer that question, you need to trace through the logic of this loop. So let's just see what happens to all the variables as we go. Initially, money is 1, and 1 is less than 8. So I enter this loop, and I double my money, so now money is 2, and now I up the number of bets to 1. Okay, so now money is 2, so I run this again, and money becomes 4, and I up the number of bets. Now the number of bets is 2. Right, now money is 4. Right, that's what I said, right? Now money is 4, so now I double my money to 8. I up the number of bets to 3. Right? Now money is 8, and 8 is less than or equal to 8, so I do run the loop again, and now bets gets skipped up to 4. Okay, so basically the way I set up the loop is the reason why you don't have an equal there. All right, so if I get that equals off, then now it's back to telling me the right thing. So anyway, just be careful that the loop that you're running that's supposed to be doing what you want it to do is only running as many times as you want to. All right, so this loop will run 1 too many times if I tweak it in the way that I showed you. Okay, so let me show you another example. What we're going to do now is write a program that calculates a factorial. And so here's the basic setup of factorials for those of you who have not seen it before or have forgotten. So if you have a positive whole number, the factorial of that number, and it's denoted n with an exclamation mark. Okay, so you're not expressing enthusiasm here. This is a technical, like it's a notational thing. N factorial is the number n itself times the number 1 less than n times the number 2 less than n all the way down to 3 times 2 times 1. So 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 5 times 4 times 3 times 2 times 1, etc. Okay, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And so on, okay? So, yeah, one thing I wanted to point out real fast is this exclamation mark is not the negation symbol in C++. It's the math factorial symbol is what I mean by this. Okay, so if you start typing exclamation marks in C++ itself, C++ will think you're saying not. It doesn't read it as a factorial. So let's write a program that lets a user enter a number and then we print n factorial to the screen. Okay, so let's think through the logic of this. The user is going to give us a number, and what we want to do now is do n times n minus 1 times n minus 2 times n minus 3, etc. all the way down. So what I'm going to do is define an integer m that's going to keep track of what number I'm at in that process. So at first, m will be n, because that's what I start with. But then m will be n minus 1, and then m will be n minus 2, etc. So m is just going to keep track of where we are in this like descending, cascading process here of computing a factorial. And factorial itself is going to be the final answer. Okay, so let's see how that goes. Well, if m is supposed to keep track of where we are in the process, right, this process of doing this multiplication, then m needs to start where n is. So m is going to start at n, and factorial is also going to start at m, which right now is equal to n. So at the very beginning here, m is equal to the number the user entered, as is factorial. Okay, so what I'm going to do is I'm going to go in this loop, and again, if m is supposed to keep track of where we are in this sequence here, this process of going down, this process continues until I reach the number 1. So it makes sense to say here, as long as m is bigger than or equal to 1, I'm going to keep this thing going. And what I'm going to do is I'm going to knock the value of m down by 1. And so I don't remember if we've seen this or not, but minus minus means take 1 away, just like plus plus means add 1. Okay, so I'm going to take 1 away from m, and then I'm going to save a new value for factorial, and it's the old value of factorial times m. Okay, so let's think of the logic of what's happening here. Originally, factorial is the number that the user entered. Right? Factorial is m, which is also equal to n. And m is also equal to the number the user entered. And what I'm going to do is knock m down by 1, so now m is n minus 1, and I'm going to tack that number onto factorial by multiplication. So let's just say the user enters the number 8, then m and factorial are both 8 right now. The first thing I do is I knock that 8 down to 7, and then I compute 8 times 7. Right? And that's the new value of factorial. And now since m is 7, I go back up to the top of the loop and start over. M is 7, I knock 7 down by 1 to 6, and now factorial is the old value of factorial, which was 8 times 7, and now I tack on a times 6. And I just keep going, right? I keep going all the way down. So that's the logic of what's happening here. So let's just do all of this. So let's run this and see if it works the way we think it will work. So give me your positive whole number. I'll give it 4. And it tells me 4 factorial is 0. Okay, I'll give it 5. 5 factorial is 0. Okay, that's obnoxious because that's not correct, right? That's not the correct value. So this program is telling me that anything factorial is 0. And that's false. Right? So something incorrect is happening here in this code. So since I wrote this, I of course know what's wrong, right? I wrote this example to make a point, but suppose you don't know what's wrong. And maybe you can see what's wrong, right? That's fine. But suppose you don't know what's wrong. Here's a little troubleshooting tip. If you don't know what's going on and you suspect something is wrong with this loop, a good thing to do is have it print out to the screen what it thinks the values of these variables are every time the loop runs. So every time the loop runs, it's going to tell you what it thinks the value of m is and what it thinks the value of factorial is. So when it prints all that information to the screen for us, maybe we can see where we made a mistake. So I'm going to enter 4 again. So what it did was, and actually maybe I should separate these so it's clearer. So sorry, let me rerun this so there's space in between. So it's going to output a value for m, output a value for factorial, and then put 2 new lines in between, so there's spacing. Okay, so what this thing is telling me is the first time the loop runs, it thinks that m is 3 and that factorial is 12. Okay, that makes sense because I started with a 4, and then I did 4 times 3, which is 12. Right here, factorial is 4, and now I take 1 away from m, and factorial is now 4 times 3. So that makes sense. The next time the loop runs, the value of m is 2. That makes sense because I knocked m down by 1. And now I take the old value of factorial, which was 12, and multiply it by 2, and I get 24. The next time the loop runs, m is now 1, and 1 times anything is itself, right? So 24 times 1 is still 24. But notice what happens here. Apparently, the loop runs again, and m is now 0. And if m is 0, well, anything times 0 is 0. So if you tack on a times 0 at the end, you kill what you had, right? So it looks like what happens is the loop runs. Let me enter 5 here, right? The loop runs properly because, okay, 5 times 4 is 20. 5 times 4 times 3 is 60. 5 times 4 times 3 times 2 is 120. 5 times 4 times 3 times 2 times 1 is still 120. Oh, but then 5 times 4 times 3 times 2 times 1 times 0 is 0. So it looks like the loop is running fine, it's just it's running one extra time. Okay? So let's try to figure out why that is. Why is it running one extra time? Well, let's just put a 3 in there so it's easier to see. If you input a 3, the first thing that happens is factorial is 3 and m is 3. When I enter the loop, the first thing I do is knock down the value of m by 1, so now m is 2, and then I do my thing, right? And then the next time the loop runs, I'm going to knock down the value of m by 1, and so now m is 1, right? And then the loop runs. But now when I get down here to the closing brace, m is 1, and 1 is bigger than or equal to 1. Okay, so if m is 1, this statement in here is still true, so the loop will run again when m is 1. Well, if you take 1 away from 1, now you're at 0. So the last time this loop runs, the value of m is 0. Okay, so that's what's happening. You're letting the loop run one too many times because you're letting the loop go when m equals 1. And then when m equals 1, m becomes 0 and kills everything. So let's just not have the loop run that many times. Let's kick it up by 1. So you can either do a greater than 1 or a greater than or equal to 2. It doesn't matter. And now let's just run it and make sure it does what it's supposed to. So I enter a 3. 3 factorial is 6. That's correct. Enter a 4. 4 factorial is 24, etc. Okay, so it works now. So again, you need to be careful and make sure that your loop is running as many times as you think it's running, or you can start getting bad answers, right? The code will run, but it won't do what you think it's going to do. Okay. So those are a couple more examples. Now let's close by talking about nested loops. So you can have loops inside of loops, inside of loops, inside of ifs, inside of another if, inside of a loop, and so on, right? You can put all of these things inside each other if you feel like it. So let's just go right back to this program here where I did a factorial calculator. So notice that what I did at the end here, at the end of the last example, I'd type a 3, the program would tell me, and then the program would end, right? So I'd have to hit play again, and it would start over, and I'd enter 4, right? Have to hit play again, 5, right? So imagine that you are writing this program for a client who doesn't want to look at code, right? They just want to run it and then just calculate things. Well, this client might want to be able to compute more than 1 factorial before the program ends. You see what I mean? They might want to compute 5 factorial, and then 6 factorial, and then 7 factorial without having to restart the program every time. Okay? So one way you can build this into your program, giving the user the ability to do this, is with a loop. So let me just initialize a string response to yes. And now let me put a loop in here. And we're going to get user input here. So let's let them enter in a little y or a capital Y. So basically, what do we want? We want that as long as the user is telling us to keep going, we want this code segment to run again. Okay, as long as they keep telling us to go, we want this code to allow them to calculate more factorials. So let me put a brace here, and I'm going to close it down here. So it seems like what we should do is, as soon as we spit out a factorial, we should now ask them, again, like, do you want to do this again without the program closing? and let's just get their response from them, right? So now what will happen? Uh, this code will run here, right? It's going to compute a factorial. It's going to output the factorial to the screen, and then it's going to ask again, and then you're going to get a response from them. And now this bigger loop, this loop right here, is over. So we're down here at the closing brace. And as long as that response is a lowercase y or an uppercase y, all this stuff will run again, right? And so notice, there's a loop inside of a loop. This little loop right here is inside this bigger loop right here. So let's just run this and see if it does what we think it should. So positive whole number 3, again, well sure. 4, again, well why not, right? So this will keep going until I tell it not to, right? So once I enter something that's not what it's expecting here, if I enter a response that's not a little y or a big Y, it'll break out of that loop and just continue with the program. So let me just do a 3 and then, oops, yes, and then a 4. And now maybe I'm done, so I hit, an end. So now it says, okay, bye. Right, so as soon as I break this condition up here, that response is y or y, it breaks out of the loop and continues on with the program. So you can have loops inside of loops. You can have ifs inside of loops, loops inside of ifs, etc. So maybe like right here, let's just say that if the number is big, whatever, you want to tell them like, wow, that's big. I don't know why you want to tell them that, but whatever. So let's just run this. So suppose I enter like a 5, right? 5 factorial is 120. Again? Well, sure. Now let me enter like a, I don't know, 15. Oh, 15 factorial is that number. Wow, that's big. Again. Okay, so you see what happened? It computed the factorial in here, and then that factorial was big, right? Bigger than 100 grand. So it told me that it was big, and now it just moves on and asks me again, right? So you can have ifs inside of loops inside of ifs to infinity, right? You can do this as much as you want. And when we start writing more sophisticated programs, like for example your group project, this will be the way that you get the computer to do these sophisticated things. So you're going to have loops inside of loops inside of loops, right? And ifs all over the place. So it's the combination of these tools that allows you to do powerful things. So I want to close this video by just showing you one more example. So nested loops can be tricky. Okay, so let me just show you an example of that. So let's start by having a couple of variables that start at 1. And, okay. I'm going to, inside the nest here, do high. I'm going to do a y++ and an x++. And actually, let's run this 3 times and 4 times, just to have smaller numbers. Okay, so suppose I give this nested loop to you, just this little code segment here, and I ask you, well, how many times does this program print the word hi to the screen? Okay, so you should probably think about that and try to guess, but it seems like a natural guess is, well, this outer loop is going to run 3 times, right? X is 1, and then I'm going to up the value of x by 1 to 2, and then from 2 to 3. Okay, so the outer loop is going to run 3 times, right? By the same logic, the inner loop will run 4 times every single time that outside loop runs. So when x is 1, right, and I enter here, this loop now runs 4 times. And then when x is 2, this loop is going to run 4 times. When x is 3, that loop is going to run 4 times. So it seems like the number of times I'm going to print hi to the screen is 12, right? 3 times 4. So that's reasonable enough. Of course, if it actually did that, then I probably wouldn't be showing you this example, but let's just run this and see what it does. Okay, so it only printed hi to the screen 4 times. So it did not do what we expected, or what you may have suspected, right? So let's just walk through the logic of what's happening here and see exactly what it did. Okay, x is 1, right? So I do enter the outer loop, right? Y is 1. So when I first enter the outer loop, I enter the inner loop, right? What does this loop do? it outputs high and then ups the value of y by 1. So y becomes 2, then y becomes 3, then y becomes 4. And as soon as y becomes 5, I break out of this loop because y must be 4 or less. So when y becomes 5, I come down here, and now x becomes 2, and now I go back to the beginning. So x is 2 now, right? X went from 1 to 2, but what is y? Well, remember, the first time we ran this little loop, the value of y was up to 5. So the second time this outer loop runs, the inner loop won't run because the value of y is 5. And you've done nothing to reset that, right? You haven't told it, well, I want y to go back to 1 or whatever you want it to do. So the value of y is 5, so the computer doesn't even go into this loop. And then the value of x goes from 2 to 3. Well, 3 is smaller than or equal to 3, so you'll enter the outer loop again. The outer loop will run 3 times, but the third time you run the outer loop, again, the value of y is 5. So this inner loop won't run. So these 4 highs come from when x was 1 and you entered this outer loop. This did print high to the screen 4 times then, but the next 2 times that the outer loop ran, nothing was printed from here. You didn't even enter this little loop inside. So if you really want the double loop, this nested loop here, to print high to the screen 12 times, as we expected, you have to reset the value of y to 1. That means that the next time the loop runs, so when you go down from this brace up to the top, now the value of y is back to 1. 1 is less than or equal to 4, and so you'll do this little inner loop again. So let's just run this and confirm that. So I should have spaced these out or something, but you can confirm there are 12 highs there, okay? So again, you have to be careful with these things, right? If you don't know exactly what you're doing, they can surprise you, right? But the computer just does what it's supposed to do, right? So if it's not doing what you think it should be doing, it is your fault, okay? But anyway, so that's all I have to say about while loops, and in the next video we will move on to a different kind of loop called a for loop.